combine with react with excess carbon 2 oxide, it will give us 84 cm cube of what? Carbon 4 oxide. That is to say, based on that, on this ratio, based on this other one, what it means is that from here, 1 cm cube of oxygen will combine with what? Will give us 22 cm cube of carbon 4. Remember, we're looking at the product. That's the product we're using now to compare which one is excess and which one is in the is limited. So then we said 42 cm cube of oxygen will then give us 2 over 1 and 42 over 1. That will 2 multiply this, will have 4. This one is 84 cm cube. Now, the one that have the highest volume of products is the one in excess. So it means that oxygen in this case is in excess. So that means for this reaction to take place, we need to find out the volume of oxygen that will burn completely 20 cm cube of what? Carbon 2 oxide from here. And if that thing happens, it means that there will be some excess of oxygen remaining. So that is what we're going to find out. Let's see how we're going to do this. Let's go together. Now we'll find out the limiting and the excess. The limiting one is what? Carbon 2 oxide. So let's see what we can do. Then we have, from our balanced chemical equation, we have that 2 cm cube of carbon. According to Lussac states that gases, when they combine in a simple ratio, in a volume that's in simple ratio with the reactants, with one another and their products. So that is to say, looking at the chemical equation we have here, that the rate of, when gases combine in a chemical reaction, what happens is that they combine in a volume that is in simple ratio with one another. They have a volume of simple ratio with one another and that of the product. That ratio is what is maintained. So based on what the user has stated, we'll be able to solve some problems using whatever the law he has already established. So in that case, we are going to be using it to solve this question we have on the board, how we can apply it in solving problems. So in this question, it said that 20 cm cube of carbon 4 is mixed and sparked with 200 cm cube of air containing 21% of oxygen. If all volumes are measured at s.t.p, that is standard temperature and pressure, they calculate the volume of the resulting gases. So in this reaction, one thing you should know that they're talking about resulting gases. That means at the end of this chemical equation, the combination of these two gases, according to that law of Lussac, according to the combination now, after the combination, the rest of the gases that will they will only combine based on the volume, the ratio of their volume of combination. Every other gas is there will not go into reaction because they are not part of that ratio. Once they get enough, no matter the volume of carbon 4 there and oxygen there, what happens is that at the end of the reaction, they will always combine based on this ratio. Now let's look at this chemical equation to find out the ratio. That means if carbon 2 and oxygen is going to be combining, they will combine in the ratio of the volume of 2 cm cube and what? 1 cm cube. Then to give us 2 cm cube of what? Carbon 4. So no matter the volume of gases you have here, they will always combine in this ratio. The rest of them will then serve as what? Resulting gases. The excess gases, the gas that may not be combining, the remaining gases, the residual gases, as the case may be. So what we have here now, based on what we have already stated here, So we can look at how we can solve this problem to get the resulting gases based on what we have. We have 20 cm cube of carbon monoxide, that is carbon 2 oxide, then combining with a gas and air that contains 21% of oxygen. The first thing we're going to do here, we need to find out, because oxygen is the only thing that can support combustion in the air. So we need to find out the volume of oxygen, actual volume of oxygen that is there already. So that's what we're going to be looking at. Let's find out how we can do this. To do this now, we know that 21%, that will give us, this can go, this will give us 2 times this will give us, I think it's 42 cm cube. 42 cm cube. That's the volume of oxygen. The volume of oxygen in the air. Volume of oxygen in that air is 242 cm cube, that 42 cm cube of oxygen. Now, what remains again here is that the rest, since we have 200 cm cube of air, the rest of them is what? Other gases we can see in the air, like nitrogen and noble gases. Other gases, volume of, we can also keep them aside. Volume of other gases in air will then be 200 minus 42. That will give us, we have I think 8, this one will give us 5, and here will give us, that is 158 cm cube of other gases that will remain here. Now remember we're looking at resulting gases. That's why this very volume will be very, very important to us at the end of the reaction. So because in this reaction, one thing you should all know here is that this thing, they will react after combination. It means that there should be something that happen at the end of the reaction. There will be some gases that will not combine. Let's go back to the chemical equation again. Let's just write it here so that we can use it to explain some things that may be necessary. So in this chemical equation, it's now obvious that we have 20 cm cube of carbon 2, then combining with 42 cm cube of oxygen. When they combine, they will combine in that simple ratio. Now, but before what we need to find out is how many volume. You note that in the ratio they should combine is 2:1. But here we have 20, we have 42. So the first thing we do here now, you notice that it means that these gases in this reaction, there is one of them that should be in excess. Some is what, one of them is also limiting. Is limited or limiting reagent. This one is excess. You see that this one is excess, this other one. But naturally, based on the calculation, we can also find out the one if we're in a case where you have problem with it, of knowing the limiting or the excess reagent. Now to get this thing done, you can compare the volume of the products they are likely to give us. Now, if we compare the volume of the product from this balanced chemical equation, it means that if 20 cm cube of carbon 2 combine with excess volume of oxygen, it will give us what? 20 cm cube of carbon 4 oxide. And from this equation we have, based on the ratio, their ratio, it means that if 42 cm cube of oxygen will combine with react with excess carbon 2 oxide, it will give us 84 cm cube of what? Carbon 4 oxide. That is to say, based on this ratio, based on this other one, what it means is that from here, 1 cm cube of oxygen will combine with what? Will give us 22 cm cube of carbon 4. Remember, we're looking at the product. That's the product we're using now to compare which one is excess and which one is in the is limited. So then we said 42 cm cube of oxygen will then give us 2 over 1 times 42 over 1. That will 2 multiply this, we have 4. This one is 84 cm cube. Now, the one that have the highest volume of products is the one in excess. So it means that oxygen in this case is in excess. So that means for this reaction to take place, we need to find out the volume of oxygen that will burn completely 20 cm cube of what? Carbon 2 oxide from here. And if that thing happens, it means that there will be some excess of oxygen remaining. So that is what we're going to find out. Let's see how we're going to do this. Just let's go together. Now we'll find out the limiting and the excess. The limiting one is what? Carbon 2 oxide. So let's see what we can do. Then we have from our balanced chemical equation, we have that 2 cm cube of carbon 2 will combine with 1 cm cube of oxygen. Then 20 cm cube of carbon 2 will combine with 1 over 2 times 20 over 1. This will cancel out. We have 10 cm cube. That means it will require 10 cm cube of oxygen to burn this completely, meaning that the remaining is in excess. So what are we doing here again? We are going to find out the volume, the volume of this, that unreacted ones, of unreacted oxygen. The volume of oxygen that did not react here. What are we going to do? That means 42 minus 10, that will give us, we have 2 here, we have 32 cm cube of what? Oxygen. This 32 cm cube of oxygen, which did not react during the combination or the spark. Now, note, we are looking for what? Resulting gases. Don't forget. So because we are looking for resulting gases, we've been able to find 2 gases that will remain. Resulting gases, the residual gases we have here now, one of them is oxygen, which is now 32 cm cube. The other gases in the that did not react in the reaction, we have others, which is 158 cm cube. I want you to pay attention to this. That's one of the ways of solving this problem, because most time I find out that most students, they have problem with this. Some students always have problem with it. That's why I need to come back to it again and look at it, because I've been receiving some messages talking about in regards to this. So that's why I need to come back to it again to throw more light on it. So let's look at this. We have this gas, the SS. We have the other gases. Now there's another gas that should be here at the end of the combustion. At the end of the combustion, we have used up is 20 cm cube of this has gone, combining with 10 cm cube of what? Oxygen. Then we just lose, well, how many? 30 out of the whole gases involved in this closed system where the combustion takes place. Now the next thing we're going to do, remember, when this one 20 cm cube of carbon 2 combined with oxygen, it also produce a gas, which is carbon 4 oxide. The carbon 4 oxide produced will then be in this ratio. Since 20 cm cube of this combined in the ratio of 20 cm cube, we'll have 20 cm cube. We may not go into doing this calculation, but if there's need for it, you can leave in the comment section. I will show you how to do this, because that's not been going, because you compare the ratio of this. If this is 2, this will give us 2. So in that case, 2 and 2, that means 20 will be 20 here. So that's how we got that one. So the next one is the carbon 4 oxide, which is 20 cm cube. 20 cm cube. These are the all the gases, the resulting gases, the total gases here. So when we sum it up, because the question wants us to find out the resulting gases, volume of the resulting gases. When we sum all these things up, what we will get will be we'll have we'll have 210 cm cube of the resulting gases. Resulting gases. That is what we have. So I thank you for being part of this class and actually watching to this point. Now, this is what we have here. But then this question will also appear in the comment section. I want you to subscribe if you are just joining us for the first time, and you have any question, leave it in the comment section there. That's where we can also that's how we can also reach you. And then share and like. Don't forget to leave your question if there's any, because I'm so interested in your success. So thank you for now. Thank you. Bye.